So to begin and to kick this afternoon's conference session, I would like to do a presentation about basically named Authentication and Configuration, which is about authentication and configuration, of course. Who among you uses or has any experience setting up PostgreSQL when it comes to authentication policies? If I name, for example, pghsbi.conf, can you raise your hand? So anybody else uses kind of automated instances, I don't know, cloud services? You can see who my employer is, where everything is basically configured for you out of the box. So let's begin with a short introduction. I have 45 minutes, should be plenty enough. But first about myself. As you may hear, I can speak also a little bit of English, I would say, if I begin to speak with a strong French accent. I'm based in Tokyo for 15 years now. So if you wish, I could also do this presentation in Japanese. Nobody may be interested in that. And I'm working on PostgreSQL since 2009, originally working on a project called PostgreSQL. And I've been involved in PostgreSQL since. I am a PostgreSQL major contributor since, I don't know when exactly, but I've been working as a committer of the project since 2018. So I've been doing mostly patch features reviews myself, commit phase management, bug fixes, and I have, I think, committed, like I did stuff before doing any kind of committer stuff. But since I became a committer, I have worked on a lot of small to middle-sized projects and did, I don't know, something like 1,000 commits into the master branch of Postgres. So perhaps you may have seen my name, I don't know. But, so I've been doing a lot of stuff around that. And I have a blog when I don't know, I try to spend some time on it from time to time, writing about new features, stuff I have in mind. You know, blogs are for yourself. So when I want something to dump somewhere, I just dump this stuff and just, sometimes people find that useful as well. So I'm working for AWS for not so long, since September 2022. And Joe Conway, who I'm also working, for example, with Joe Conway, who did a presentation with the ICU collection, and we do community stuff focused really on PostgreSQL and upstream work. So today's agenda is unsurprisingly about authentication configuration, but I also want to show a few things, present a few things about PostgreSQL 16. Some of you may have seen this morning's presentation from Amit, who did actually. Okay, so he has presented stuff about new features of PostgreSQL 16, and he has not covered at all what's in this presentation. So you can have there is basically no overlap between what's in this last section of the talk and what Amit has presented. This is around the work I didn't do myself, but I've committed most of the work that's in this talk. So a few words about authentication methods. PostgreSQL has a large history of authentication itself. Since it came out as a Berkeley project, I think we have password-based authentication since those time. You can look at the history of the Git repository itself to have an idea. Perhaps I'm just mistaken in saying what I said now, but we have a hell lot of methods and things you can use to do authentication in PostgreSQL. Some of them being famously unsecure, I would say. You can use things like plain text, MD5 hashed passwords, something which is much newer than that since PostgreSQL 10 is called SCRAM, based on an RFC. I don't remember the number of the RFC, but it's designed to be a much more secure password-based approach. But there is so much more than that, like radius, something that's supported for a pretty long time, that I've never used myself. I don't know if a lot of people have used that, but you have also things like LDAP, PAM, BSD-based things. Just to name a few things: certificates-based authentication, peer for local connections, and even more things like Kerberos or SSBI, which are, I mean, a lot of those things are very popular. Everybody has their own use cases. You may have used some of them. Most of them, perhaps you have not used them. Each one have their own use cases and things to look at after. I'm not going to cover all of them, just a few of them. If you have questions specific to some authentication methods, I may be able to answer them. Specific details, perhaps not, because it's a very wide and complex topic on its own. So for what's worth, I have worked as one of the original authors, for example, for the SCRAM one. So if you have a question about that, most likely I would be able to answer it, which would be okay. Other cases are also fine. It's an area of the code I'm kind of very used to, especially lately. So who knows what the trust method is? Like, you don't need to read that yet. So have you used it in production? Yes? No? Yes? Oh, you. Yeah, so...
defense, it was for one IP address machine.
Yeah, you call that defense, right?
You had to set up reverse DNS to get it to actually work.
Yeah, so when it comes to PostgreSQL, it's the authentication method that has absolutely zero security and basically no valid cases, except if you have some personal environment you wish to use PostgreSQL to test it, basically. Protocol-wise, it's basically something that PostgreSQL sees immediately and just accepts a connection like blindly. So it's really just something, I trust everything, and everything is able to log in and connect directly. You would be surprised, but I saw reports in the past that they are outside on open IPs, a lot of instances of PostgreSQL running on the default ports that you can basically just connect to if you wish to. And these are kind of trusted, like, entirely. I mean, I think it's still the case today. There are hundreds, thousands, or even more instances that people just like deploying with, you know, the easy configuration. See, oh, it actually works. I can just connect. And I mean, such unsecure setups are not as uncommon as you would think. So basically, never use it. If you have anything, perhaps, yeah, it's, I don't know, for a custom setup, using some that with some Unix domain sockets that you actually control even in your own laptop. If you are, I don't know, if you use a shared development environment or anything like that, would make sense also in this case. PostgreSQL has a lot of configuration on that. It was actually the origin of CVE a few years ago. I think in 2015, 14-ish. That Noah Mish has fixed about that. When you actually run make in a shared environment, you would be able to plug into an existing version of Postgres running, even if it's a temporary one for the regression tests, and you would be able to just run queries into it and be able to hack the account using that. So we are much better on this side now. Just usually you shouldn't try to use it. Something also very insecure is, especially if you do not use any kind of encrypted connection, is a plain text. Basically, you have the client and the server, and the client kind of is being asked by the server to, please, could you send your password? The client does so, just as a simple string, and then the server compares that. Basically, we have removed support for that internally, meaning that, for example, if you can also always request the server at protocol level to have the authentication happening using that, if you look at the code, It's still supported at the protocol level, but clear text passwords cannot be stored in catalogs anymore, I think since PostgreSQL 10, actually. So what happens internally is that even if you use this clear text protocol connection for authentication, what PostgreSQL internally does is looking at the PG auth ID catalog and compiles an MD5 hash string, or even it could be a SCRAM hash of the password itself, compiles it, and then does a comparison of that before sending it back, the answer back to the client. Of course, it's just a simple string and no hashing is applied to the password itself. It's weak to what's written on the slide as a password sniffing. For example, if somebody is looking at your connection, he would be able to get back or some information about the password or just bytes of it or anything. So you should definitely use SSL, not only in this case, but also on that. As I mentioned, the catalog PG auth ID that stores the information about roles and users, and also the password hashes, stores only MD5 or SCRAM hashes for the plain text password. So one thing also, which is the last point of this slide, is that the protocol-wise, the server tells back to the client that the password matched, but if you are actually connecting into the rogue server, the server may as well just lie back for the client and just say, yeah, I know it. But if you connect it to the incorrect server, it may be able that you're actually feeding your actual and real password to the client, to the server, and inform somebody about your password in this case. So protocol-wise, it's also kind of unwise to use. Something a bit more advanced that exists in PostgreSQL for a very long time is MD5 based password protocol, which is a little bit more advanced than that. When you connect into PostgreSQL, the server says back to the client, okay, here's a sort of 4 random bytes. Could you, please, client, compute MD5 hash of this thing, of what you think is the password? And you need to use your username as well as the sort using a double MD5 computation. Once you compile that, please send it back to me. The client does so, sends back the hash back into the client, into the server. The server does the same computation, compares it, and says it's also good to go. Again, if you compare that with the clear text password authentication, a server could lie basically and say, yeah, of course, I know the password, and just lie it, and you will be able to get back a hash of what's, I mean, the server would be able to get a hash of what has been happening from the client in this case. Something to be very careful about is, I'm not sure if I have that in slide after or not, but some of you may have heard about what is called a pass the hash attack. Do you know what that is or not? So the idea is that if the server, I mean, if an attacker only knows, I mean, if an attacker knows does not necessarily need to know the password to be able to connect to a server if he actually knows the MD5 hash of a given password. So basically, if you have a cold backup with contents of PG authentication ID that stores old, not clear text passwords, but MD5 hashes in that, somebody could use actually those MD5 hashes and still be able to connect to PostgreSQL without knowing the actual password. So MD5 on this side is quite insecure. It's quite popular depending on your backup retention to have old data folders lying around on some old server. Your servers get, I don't know, attacked, or you have an issue with them. And if somebody is able to get access to the on-disk data and the on-disk contents of PG auth ID, which can also just be looked at or just copied over, because it's only those 8K pages stored in PostgreSQL itself, somebody could be able to retrieve an MD5 hash and use this pass the hash vulnerability, classified as such, to bypass the fact that an attacker does not need to know the password to be able to connect to PostgreSQL itself. So a much more advanced password method is called SCRAM Channel 256 that has been added in PostgreSQL 10. It's based on an RFC from 2017, 2016. I don't remember which one it is, but originally it was based on SHA-1. This has been implemented in PostgreSQL 10. At this time, we also had a refreshed RFC that has been based on SHA-256, which is much stronger hash-based. The protocol is challenge-based, meaning that you have as additional fact that the server needs to actually has to send a proof back to the client that it knows the password. So in this case, it's not possible for the password to fake that it knows the password, contrary to the clear text or even the MD5 string. So what happens in this case is that the client sends a random nonce. The server uses it with a sort and iteration count and sends back an answer back to the client that it actually knows the password as well. You have kind of an extra exchange in this case that when the client compiles anything it needs for the exchange protocol, that the client can also check that the server actually knows the password as well, kind of contrary to what MD5 or even clear text does, which is very good protocol-wise. It's also something that client libraries need to implement by themselves, this extra check, which is something that JDBC does, speaking directly the protocol, or even LPQ also does as well. If you look at the code, you can get an idea of what kind of messages get exchanged between the server and the client, and the fact that not only the server checks that the client knows the password, but on the other side, the client also checks that the server itself knows that. So it's not really possible for the client or the server to protocol-wise to fake each other in this case, meaning that if you connect to an instance, you can basically know if the server is telling the truth from the client side, and you can also know the server also would be sure about that in this case as well. SCRAM also is designed for security, meaning that it's actually, it can be much stronger than MD5 when it comes to reply attacks. For example, if you use longer nonces, the hash of the SCRAM password is stored in PG auth ID with some extra data to be able to recompile the data in it. So you have, if you, for example, create a new password for a user, you would have a SCRAM-256 using an iteration count, and also you have some extra data used in this identifier itself. Something to be aware of is that the SCRAM identifier, in this case, the SCRAM secret, is compatible with the LDAP implementation, which is also listed in a different RFC itself. So the iteration count, protocol-wise, can be used as a parameter, and the code and implementation of SCRAM in PostgreSQL is pluggable regarding all those parameters, like the nonce length as well, meaning that you could even have your own SCRAM secrets based on a set of parameters, and PostgreSQL would be able to cope with that and work even protocol-wise. The code is very, very flexible on that. Something to be very careful about is that even if you use that, your connection would be kind of weak to password sniffing issues, even if the hash is much stronger, meaning that you should still use SSL. And things like, for example, channel binding, which is in this case a connection parameter coming from libpq, like channel binding require. The thing is that protocol-wise, or even in the RFC, the server has to know the password, but also the client should check the proof sent back from the server, meaning that the client should really check for the proof, but you'd better make sure that if you are using a dedicated client library, that when you do a SCRAM authentication, the client library you are using and the client library that's speaking the PostgreSQL protocol actually checks for the proof as well. I think JDBC does that. libpq, of course, does that. It's internally into PostgreSQL. But just be careful about that, because if you do not actually check the proof, it could still be possible for the server to send some fake data and say, yeah, of course, I know the password. But if on the client side, you do not actually check that the proof is correct, you may still be, a server may be able to trick you into connect into a server you should actually not try to connect to. So something that's very important on this side is called, it's the SCRAM channel binding, which is a protocol to make sure that if from one client position you are trying to connect to a given server, you still have the guarantee that you are still connected at the same point after you have done the SCRAM exchange. The SCRAM channel binding that's been added in the PostgreSQL 11, not 10, that actually I wrote, is a mechanism to prevent man-in-the-middle attack that checks after you have done the SCRAM exchange. I think it's actually, no, it's actually not at the end of the SCRAM exchange. It's during the hash exchange. We check on the, I think it was on the client side, I don't remember correctly. But we actually check that that the point where we are connected to is still the same using some of the internal OpenSSL APIs. The data we use for that is a hash of the certificate coming from the server, and we check that on the client side. Channel binding has several types. PostgreSQL implements what's called TLS server endpoints, which is a hash of the certificate coming from the server itself, from the peer connection. There is much more to that. Like new RFCs have new channel binding types, like one is called TLS exporter, that's specific to TLS version 3. But that's not available in PostgreSQL yet. You can use TLS version 3, of course, when you connect to PostgreSQL, or you could even enforce it using libpq and some of the connection parameters to do that. There have been some challenges around that in PostgreSQL because the fact of supporting multiple channel binding types also requires some extra facilities, like the channel binding type you will like to use and the negotiation that you will need to have between the client and the server itself. So Jacob Champion, who is not at this conference today, has sent some patches to do that. Still, that's a pretty challenging area. And the use cases compared to TLS server endpoint are not completely sure if it's really worth to have this kind of extra facility and the benefits you would get from it. So we don't have any improvement on that in PostgreSQL 16, perhaps not 17, we'll see about that. But the discussion on that has stalled a little bit. It doesn't mean that TLS server endpoint is bad. Actually, you should definitely use it, such as you make sure that the connection, that the server you are connecting to is still the same as the one when you started the connection with the same SSL handshake. And you should definitely use the connection parameter called channel binding and enforce it to require with an SSL connection where you connect to PostgreSQL and SCRAM. That's kind of a good security practice on this side. Something that comes to password encryption, to password configuration, is that you can store only in the PG auth ID catalog, as I mentioned before, MD5 or SCRAM hashes or verifiers. In this case, you can only store those two ones. But pghba.conf can be configured with multiple keywords to enforce what PostgreSQL will use as protocol. The thing is that you can, for example, have a role that has an MD5 hash or SCRAM hash, and PostgreSQL would be able to work and compile on the fly hashes of the stored result and then compare them. Such as, for example, you could have a given configuration that uses password to enforce a clear text password, but you can also have in the catalog an MD5 hash or a SCRAM hash. So using password would be able to work even if a role has an MD5 or SCRAM hash stored in the PG auth ID. If you use MD5, actually, surprisingly, it works with the MD5, of course, but if you have even SCRAM getting used, it would actually be able to work as well. So it's, yes, so the user has a SCRAM hash password, and pghba.conf has MD5 stored in it, but under the ground, PostgreSQL does not use MD5, it just uses SCRAM, which is something that has been chosen in PostgreSQL 10 to make sure that if you upgrade from a server older than 10, like 9.5, 9.6, to 10 or even 11 or newer version, you don't need actually to change PostgreSQL, the pghba.conf, and you can still use the same HBA entries. You don't actually need to write SCRAM for that. If you have a SCRAM entry and an MD5 hashed password stored, it's not going to work. You need to have a SCRAM verifier for the user in this case. So another connection, another authentication method that's quite, perhaps not that much used, still quite popular when it comes to local services. If you have an application and PostgreSQL stored on the same host, you may actually want to rely on that. It's the possibility to use Unix socket connections and local connections using the OS call in the kernel itself called getPeerID to make sure that you get a correct mapping between the OS user and the PostgreSQL user you wish to connect to. This is in par with pgident.conf, and perhaps some, if you have some static service files, you will be able to connect to it. I'm just coming into the configuration part of all that in a few slides. For example, if you want, I don't know, you have a PostgreSQL instance and on the same host, you would like to get some, I have designed in the past different services like a local WAL archiver that would actually pull data using, pull data from PostgreSQL using a PG receive WAL. This kind of thing to be able to look to do a local archive of a PG WAL. So I use that, for example, with the static servers or even monitoring agents. These days, you can also do that with background workers, for example, that exists in PostgreSQL since PostgreSQL 9.3 as a PostgreSQL process running and doing such tasks on a periodic basis. For example, who knows PGCon? So if you've been using PGCon, it's the possibility to do periodic basis using internal PostgreSQL processes loaded by PostgreSQL and running this way. I've been using different services to be able to do that, for example, in the past with a peer connection for local connections. You have things also like LDAP, which is a server-side implementation. If you use LDAP, and from the viewpoint of the client, what you use is clear text password connection. So you cannot use any type of hashes, any type of hash computations in this case. The client sends this data to the server as a clear text password, and then the server connects to the LDAP server to do any kind of check, depending on the policy you have, what you actually want to achieve. PostgreSQL supports many things like prefix, suffix. SSL is mandatory because of the fact that the server and the client use clear text passwords. But you can have a lot of password policies. which is sometimes suited for PostgreSQL instances and large organizations that I've seen in the past getting used, for example. So you have also something very popular. It's GSS Kerberos or even SSPI on Windows. It uses Kerberos when Active Directory is available. It uses also the client tickets that you have and pghpa.conf. This should use encrypted connections. And something which is a little bit handled separately protocol-wise is the possibility to connect to PostgreSQL using certificates. You can enforce what the client checks using something like SSL mode, for example. And also pgident.conf. This is only available in SSH. So PostgreSQL is quite better at that compared to what happens in the past. Like if you implemented a patch 10 years ago, we did not have the possibility to have complex regression test scenario or anything. These days, any new feature that happens in PostgreSQL has to have tests. I mean, we actually require tests. We have a lot of things getting added. And we are at the point where when a new feature is added and you don't have any tests or you cannot design any tests, the feature will likely not get committed as it is with the current pool of committers, I guess. So we have expanded a lot of things to get regression tests or an idea of how things happen in PostgreSQL, even at configuration level. It can be quite a good study if you are new to Postgres and would like to use at special areas. In those cases, look at SRC tests. We have authentication tests, Kerberos, LDAP, SSL. These require an extra environment variable called pgtest extra because those tests are not secure to be run by default because they require extra configuration, which could be an issue if you, for example, have a development environment in a shared host and you don't want to trust other users as well. You can use proof tests to run a subset of them. And we basically are at the point in PostgreSQL where we require those things for any new features getting added. At least any patches I've been committing into PostgreSQL has required that all the time. So I wanted to talk a little bit about the configuration and such. First, when it comes to the code of PostgreSQL and authentication, you would likely need to look at SRC backend libpq when it comes for anything handled in the backend on the server side of PostgreSQL itself. The main files are auth.c or auth-scram.c. We have also kind of a rather clean state of the code when it comes to anything related to encryption. So B is for backend secure.c. We have files for SSPI, SSL, and we've been also working on shaping a code a little bit more so as potentially, even if it's a very difficult discussion, new SSL implementations other than OpenSSL could be integrated with PostgreSQL. At least the code is in a state where this is much easier to do, I guess. Something also, an important part of that is HBA.c, which is related to pghba.conf, where when we evaluate HBA entries, everything happens in that. The code also in this area has been refactored a little bit, such as we separate the internal core code of HBA.c and anything, for example, related to the SQL functions we have, because we have a few catalog views that can be used to view what's actually at the SQL level, what's in the files stored in that. After that, you have the front end, anything related to libpq itself. We have kind of the same split for authentication, SCRAM things, and also the same secure parts. Like it's really thought to be rather a mirror of the back-end code, but this time for the front end and libpq. So anything related to the protocol, SSL, SSPI, is well documented, so it may be worth a look if you are interested in anything related to that. So about the configuration itself, we have pghba.conf, which is basically a policy file that lists a set of rules based on users, databases. For each one of them, you can specify a list of them, a host, which is optional depending on the type of authentication type you want to use. For example, if you have an entry where you want only local connections, host is not something that's available because it doesn't make any sense in itself. Extra options are also possible. You can specify a map, which would be related to pgident.conf, for example. And the PostgreSQL code is shaped in such a way that when we do the authentication protocol, we check the username, the database name, and the connection type we have. And we basically check for matches. And once one entry matches, PostgreSQL will switch to the authentication exchange and send back to the server a given authentication code to say, OK, I'm going to move on with this type of authentication. Something very important in PostgreSQL itself is listen addresses, which can be set as a postmaster parameter, meaning that any changes in that requires PostgreSQL to be restarted. That defines a list of IPs authorized to connect to PostgreSQL. You could use something like an a character to authorize all IPs, and then have a set of filters in pghba.conf, for example. But just be careful with this parameter and to not authorize too many things if you want your environment to be restricted when it comes to connection. We also have checks like role membership or even a keyword called all that would authorize, for example, all users or all databases to be connected, helping with a lot with the filtering of the things happening. Something that PostgreSQL uses in the configuration is the possibility to define include files when it comes to usernames or even databases. I mentioned a little bit before that you can specify lists for each one of them. So I have a very small question for you, if you can reply to it. I have those two cases down here. How do you think this behaves when it comes to PostgreSQL? Anybody has an idea or not? Or you trust me so much that you kind of just want to wait for my reply? So the thing is that the PostgreSQL parsing code, when it comes to the HBA code, is very, very flexible. So you can define include lists, and as long as each entry is comma separated, separated by a space or even with a new line, each one of those things are considered as separate entries in the list. So specifying in an include file a list of usernames on the same line separated by with a commas or even separated list would mean that on the left side you would have an HBA entry considering a list of 3 users and on the second one of 5 users. This is not documented much in PostgreSQL itself, but it's something that can be very flexible when it comes to having complex policies based on the users you have and what you actually want to set up for PostgreSQL authentication as well. So you have also pgident.conf, which is a complement to pghba.conf. Depending on the entry policy you want to use, for example, with things like Kerberos or even ident authentication, peer authentication, you can use a mapping between the OS user and the database user itself and have extra checks based on that. You can specify regular expressions for the system user, which would be the second column in the ident entries, to have much more complex policies, which is very, very useful when it comes to Kerberos, because usually people have a lot of Kerberos users using a given a domain name. And you could basically say that I have role@domain.com mapping to a given PostgreSQL user using, for example, replacement of \1 to say that this is internally only the PostgreSQL user without the @domain.com name. So you can do a kind of one-one mapping and much more complex policies when it comes to the user used by the client when it comes to the connection and what PostgreSQL stores internally. It's possible. It's written like in a very small, in a few characters in the PostgreSQL documentation, but it happens that you can specify multiple times the same mapping name to be able to check what happens. So for example, you have this simple configuration based on pghba.conf, pgident.conf, which is a peer authentication to only authorize local connections. You can specify a map, which is in this case my map, and pgident.conf can include multiple entries to check that your system user number 1 or 2 matches with a system with a PostgreSQL user in this case. So you can have much more complex policies, authentication policies, using a trick of the same map name and multiple entries like that. You have also pgservice.conf that can be used, for example, for static services to connect to a given PostgreSQL instance. I'm not sure it's actually that much used by people. Has somebody set up any kind of service files for, I don't know, applications running as services in hosts or PostgreSQL? Have you done that? Could you raise your hand? It's not that much popular. So you can use also connection parameters to use a given service name. If you have one service file, for example, I mean, it can be kind of useful depending on the cases of what you're actually trying to do from the clients, if you have specific services or I don't know. Something that's very important is that we have the connection parameter called the SSL mode that controls if PostgreSQL should use or enforce SSL. I mentioned a little bit earlier in this talk that if you use any kind of password-based authentication, using SSL is a must-have in terms of security. But it's not only that. PostgreSQL default is to prefer SSL connections, which is completely crazy, because if you actually use that, it's called like prefer. What LPQ does internally is to try an SSL connection first. If it fails, underground, it would actually switch to a non-SSL connection, meaning that you may silently finish by connecting into PostgreSQL instance without any encryption and your application not knowing about that. You should use, Require has its own benefits of making sure that PostgreSQL uses an SSL connection when you connect, but you should be much stronger than that. Usually what you should try to use is verify-ca or verify-full to make sure that you have much more checks happening underground and much more protection. So this kind of summarizes what kind of protection you get. Protection from man-in-the-middle attacks or even eavesdropping connection, depending on what the SSL mode has. Usually, you should try to use a verify full, which also provides on top of a certificate check that the CN field in the certificate also matches with what the client has used as IP. So I don't have a lot of time left, but I wanted to outline a few things about PostgreSQL 16 that have not been mentioned. The first thing is that pgident and pglpa.conf authorize now, like PostgreSQL.conf, the possibility to include files, directories that have configuration files. So like PostgreSQL.conf, you can basically now spread HBA policies or ident policies across multiple files. This has come up as a use case for containers. For example, people willing to deploy in a given folder new files configuration or help with a switch configurations easily by switching files. If you actually want to switch between something that blocks SSL or not, it happens that switching between files can be much easier than having to hack on the pghpa.conf itself, because you can isolate changes you want to have. Like PostgreSQL.conf, we have include and include if exists as rule to make sure that a file exists or not, optionally. So everything is actually now much more consistent with PostgreSQL.conf and what PostgreSQL.conf can do, except that you can do it with pghba.conf and pgident.conf with all kind of fancy policies you want to do. Something that PostgreSQL was not good at doing is checking that include files do not recurse into themselves as well. For example, if you try to do something like that, pghba.conf entry referring to itself, before PostgreSQL 16, you would get a weird error that you don't know actually what's happening. The code has been reworked to actually add some correct information about what's happening and the state of the full inclusion state as well. So a lot of cleanup has happened in this area for PostgreSQL 16. So it makes handling and configuration of PostgreSQL much, much easier. In PGHBA.conf, we have added the possibility to specify regular expressions for databases and roles. So you can, for example, now you can also specify regular expression as a member of the list of things, but you can, depending on what the client is requesting, match with certain database pattern names or even user pattern names. This can simplify a lot the life of people because you don't need to write thousands of entries depending on the roles you want to match to, sub-patterns of role you want to match to. And particularly, this is much more useful when it comes to pghba.conf because we do the pgident.conf because we actually check for the pgident matching after making sure that the HBA entry has matched. So if the HBA entry has matched, but you actually failed pgident.conf, the authentication would fail and you would not move on with the follow-up HBA entries. This can be very, very useful when it comes to complex policies, authentication policies using PostgreSQL. Also, in the pgident.conf, the thing has been extended to support the same keywords and grammar as pghba.conf for databases and users. So you can use now for the PostgreSQL username the keyword all to say that I accept for example, this system user that all PostgreSQL usernames are allowed. This would basically, this is the same kind of rules of pghba.conf as a keyword. We also have the possibility now to define memberships for a given role. For example, if you take the system user 2 in this case, you would be able to authorize connections for any role that's a member of the role defined in the PostgreSQL username. Perhaps I lost you here. But you can also do that with regular expressions. If you have, for example, say local connection and an OS user called system user 3, and you're trying to connect to a PostgreSQL instance using a given PostgreSQL name, you can check also for sub-patterns of that. In this case, that would be something named PG user with like an integer digit between 2 and 4 in this case, but you can do all kinds of crazy things you want to do. It's quite flexible. And the nice part of that is that the code now between actually it's pghba.conf and pgident is shared because we apply the same keyword rules, the same ordering of rules between all the files. So it makes the code much, much more consistent while providing also a lot of new features. The system views that we have, pghba file rules and pgident file mappings, have new fields to provide data about the origin file and the file, the file name that would show you from which file a given rule is. And we have also introduced the kind of ordering counter to be able to check in which order rules would be checked when it comes to pghba.conf or even pgident.conf. Before PostgreSQL 15, you would be able to do that because pgident.conf or pghba.conf were in a single file, and we had the line number, so you will know based on the line number which rule will be applied first. Now you can basically have crazy structures of configuration with, I don't know, a lot of files inside it, a lot of inclusions, and you could be able, but the thing is that this rule number or the mapping number allows you to track immediately. Yes?
Is it indent or ident?
Sorry?
Ident. I think it is extra file in the name of the...
Yes, it's not indent, thank you, it's ident. pgident file mappings, yes, thank you. I mean, yeah, it's something also I do a lot. It's a mistake I have a lot in when it comes to typing that. It's a PG ident file mappings. I will fix the slides before sending that to the conference.
Probably the same type on slide 27 as well.
Okay, I think so about that. I check after that. Yeah, sure. Thank you. So you can see the mapping ordering and the rule ordering when it comes to that. You need to note that there is no actual changes in PostgreSQL about the way we do that. When you query those catalogs, it refers to the state which is in the files themselves, not what PostgreSQL has loaded. So if you, for example, edit those files and query those catalogs, you shouldn't do that perhaps on a new connection. I mean, PostgreSQL would need a reload to reload the new rules, but just be careful when you edit it. Those catalogs do not reflect what PostgreSQL has loaded in memory, but what's actually in the files themselves. It's actually can be very useful for when it comes to debugging, because we also provide error context for anything that happens, like, I don't know, a regular expression is not correctly written or anything like that. Those catalogs are very, very useful when it comes to debug any kind of things you have been doing with the complex file structures, especially now that you can use regular expressions or even include files, which can make things completely hairy when it comes to debug PostgreSQL instances, and making sure that what you do is what you actually want to do. Authentication and connection define what makes a PostgreSQL instance secure or insecure for your users. So that's kind of a key thing to remember. If you doubt about the contents of pghba.conf, what kind of things should be applied, I mean, look at those catalogs. I mean, these are very, very important when it comes to anything you are touching in this area, I think. libpq also has a new set of few features when it comes to that. Amit has mentioned this morning that we have a new connection parameters that allows you to require certain authentication types. You can, for example, enforce now on the client side if you want a client to use SCRAM authentication. The implementation is protocol agnostic based on what libpq has. So it's based on the authentication codes that we use in PostgreSQL internally. But there is much more than that, like SSL certificate mode that allows you to require a certificate to be used. SSL root cert has also a new system rule that checks the system's CA in this case, enforcing also SSL mode to be used, and also SCRAM iterations that checks, that allows somebody to control the number of iterations used when you compile a SCRAM hash for a password. So a low number means that you are basically weaker to replay attacks, but the authentication is much faster. We found cases for both of them. A high number makes things harder to crack, but the authentication gets very slower. If, for example, you have an iteration, I don't know, a few million, it can take really from a few milliseconds to seconds to actually authenticate in this case. So be very careful when it comes to that. But the protocol and code are very, very flexible when it comes to such changes. I took a very long time to do that, so we don't have much time. I wanted to thank you today to come to this presentation. If you have any questions, feel free. We are a little bit over time, so perhaps I can also take any questions offline if you have anything. If you have complaints about the authentication code, it's kind of the area I worked on for Postgres 16, and I think I was one of the only guys doing that. So if something is broken for a reason or another, likely you would need to blame me when it comes to it. So just, I don't know. That would be my side of things. Thank you.